An operating system, sometimes abbreviated as OS, is a software program that enables the computer hardware to communicate and operate with the computer software. It manages the computer's memory, processes, and all of its software and hardware. It also allows you to communicate with the computer without knowing how to speak the computer's language. The graphical user interface lets you use your mouse to click icons, buttons, and menus, and everything is clearly displayed on the screen using a combination of graphics and text. Common desktop operating systems include Windows, Mac OS X, and Linux. While Windows and Linux can be installed on standard PC hardware, Mac OS X can only run on Macintosh computers. Therefore, the hardware you choose affects what operating system you can run. Operating systems perform basic tasks, such as recognizing input from the keyboard, sending output to the display screen, keeping track of files and directories on the disk, and controlling peripheral devices such as disk drives and printers. It simply manages the hardware and software resources of the system. It simply provides a stable, consistent way for applications to deal with the hardware without having to know all the details of the hardware. For large systems, the operating system has even greater responsibilities and powers. It is like a traffic cop. It makes sure that different programs and users running at the same time do not interfere with each other. The operating system is also responsible for security, ensuring that unauthorized users do not access the system. A modern operating system must also provide various levels of operating system security, including directory and file security, memory security and resource security. In a multitasking operating system, multiple programs can be running at the same time. In this case, the operating system schedules each task and allocates a small amount of time for the execution of that task. In reality, a multitasking operating system runs only one program at a time, but it jumps from one program to the next so quickly that it appears as if multiple programs are being executed at the same time. The users of batch operating system do not interact with the computer directly. Each user prepares his job on an offline device like punch cards and submits it to the computer operator. To speed up processing, jobs with similar needs are batched together and run as a group. Thus, the programmers left their programs with the operator. The operator then sorts programs into batches with similar requirements. Jobs residing in mass storage wait for execution in a job queue. A queue is a storage organization in which objects are ordered in first out fashion. That is, objects are removed from the queue in the order they arrive. In early operating systems, each job was accompanied by a series of instructions explaining the steps required to prepare the machine for this particular job. Those instructions were written using a system known as JCL, Job Control Language, and stored with the job in the job queue. Time sharing is a technique which enables many people, located at various terminals, to use a particular computer system at the same time. Time sharing or multitasking is a logical extension of multi-programming. Processor's time which is shared among multiple users simultaneously is termed as time sharing. The main difference between multi-programmed batch systems and time-sharing systems is that in case of multi-programmed batch systems, objective is to maximize processor use, whereas in time-sharing systems objective is to minimize response time. Multiple jobs are executed by the CPU by switching between them, but the switches occur so frequently. Thus, the user can receive an immediate response. For example, in a transaction processing, processor execute each user program in a short burst or quantum of computation. That is, if n users are present, each user can get time quantum. When the user submits the command, the response time is in few seconds at most. Operating system uses CPU scheduling and multi-programming to provide each user with a small portion of a time. Computer systems that were designed primarily as batch systems have been modified to time-sharing systems. Distributed systems use multiple central processors to serve multiple real-time application and multiple users. Data processing jobs are distributed among the processors accordingly to which one can perform each job most efficiently. The processors communicate with one another through various communication lines, such as high-speed buses or telephone lines. These are referred as loosely coupled systems or distributed systems. Processors in a distributed system may vary in size and function. These processors are referred as sites, nodes, computers and so on. Real-time systems are used when there are rigid time requirements on the operation of a processor. Or the flow of data, and real-time systems can be used as a control device in a dedicated application. Real-time operating system has well-defined, fixed time constraints, otherwise system will fail. For example, scientific experiments, medical imaging systems, industrial control systems, weapon systems, robots, and home applicants controllers, air traffic control system, etc. Network operating system runs on a server, and provides server the capability to manage data, users, groups, security, applications, and other networking functions. The primary purpose of the network operating system is to allow shared file and printer access among multiple computers in a network. Typically a local area network, LAN, a private network, or two other networks. Examples of network operating systems are Microsoft Windows Server 2003, Microsoft Windows Server 2008, Unix, Linux, Mac OS X, Novel NetWare, and BSD.